All right. Now we're going to close up with a discussion about misleading statistics. I'll try and stay away from politics and the, fake news thing. I didn't say that. Okay, misleading statistics. So many people believe that you can make statistics say anything you want. You can lie using statistics. Now, that's not true. Now, you can lie. You can, if the number is 6 and you erase it and put a 10, then that's you lying. That's not the numbers lying. That's you lying outright. But when we say we can make the numbers say anything we want, we're not talking about deliberately erasing a number and putting another number in. We're just saying, oh, you know what? We can use statistics to make it look like the numbers are high or low. We can then make statistics say anything we want. And again, that's not true. And that's because statistics have rules. Now, there's wiggle room in the rules. So to the extent that there's some wiggle room, you can get numbers that are a little higher than others, lower than others. And if you choose to be less than, forthright, less than entirely honest, then you might choose the smaller number. All right, or you might choose the larger number. And again, you're taking advantage of the fact that there's wiggle room in some statistics. But you cannot use statistics to say something is black when it's white or white when it's black. All right, there's going to be limitations. Now, you can, though, if you know a lot about statistics, you can take advantage of people who don't know about statistics and you can mislead them. So the first way that you can mislead somebody is to be very, very vague. So if I were to tell you that the average household income in Cedar City is $65,000, you might think that that's pretty decent, or maybe not, right? But I could be misleading you because I didn't tell you how I measured average. An average, the three most common ways of measuring an average is by either calculating the mean, the mode, which is the most frequent score, or the median, which is the score that divides your numbers in half. Once you order them from lowest to highest, what number is smack dab in the middle? So lots of times those three numbers will not agree with each other. So I might be choosing 65 because, regardless of, whether it's the mean, median, or mode, I might be choosing that number because I think it supports my argument. Cedar City needs more help. They're only making $65,000 a year. Or Cedar City doesn't need help. They're making $65,000 a year. All right. So I'm choosing the number based on what I want to say. All right. Instead of asking, well, which one should I use? Mean, median, or mode, based on which one more accurately reflects what's going on. So you can mislead people by being very vague, describing your statistics. Another way you can mislead is by using graphs. Graphs can be used to mislead people. So this is an example that I have in the book. I'll go over it here in this little video lecture. Let's say that I am interested in studying cats and dogs. So here's my independent variable. I've got two groups. So animal is or pet is my independent variable, and I've got cats and dogs as the two levels. And my dependent variable over here is mean licks. Oh, that should be saying per hour, not hour. Mean licks per hour. All right, so I want to know if the type of animal or pet has an effect on licking behavior. And they're licking themselves, just so you know. So I can look at this and say, oh, you know what? There's not a huge difference between self-licking in cats versus dogs. So it's a relatively small difference. Then I can look at this data set and say, whoa, wait a second here. This one actually found a pretty large difference. So here it's a small jump, and here it's a much larger jump between cats and dogs. Or is it? Right? Is it really the case that this is a bigger difference than this? And the answer is no. This is actually the identical data set. All right, how do I know? Because I created it. And here, what I've done is I've shown you cats versus dogs, but from a distance. In other words, it's like you're looking at them from far, far away. When you're looking at something from far, far away, it's hard to pick out the details. And I do that by making this scale here go from 0 to 50. All right. So when I have a scale that goes, with this huge range of values, I'm going to zoom out on the difference between cats and dogs. But look what happens down here. If I zoom in, so instead of 0 to 50, I'm going to zoom in to 0 to 25. Now, all of a sudden, the difference between cats and dogs doesn't look, it looks larger, right? It looks to be a lot bigger than what it did when we were zoomed out. So zooming out by having a large range of values on your y-axis, zooming out will minimize the difference between groups. Well, it will look like it's been minimized, right? Whereas if you zoom in by having a smaller range of values on the y-axis, zooming in makes any difference seem much larger. But again, in reality, the difference between the top and the bottom is the same, right? The difference between cats and dogs, it's the same. It's just that I can change the way it appears by zooming in or zooming out. So that's another way in which graphs can be misleading. And what you need to do as a critical consumer is always look at the y-axis. All right, and then just look at the numbers. This one, cats, they self-lick, 23 times on average every hour, whereas dogs are right around 15. And if you went up here, you'd come to the same conclusion, around 23 and around 15. All right, so always look at your y-axis. Don't just look visually at the bars. You've got to look here at the y-axis. How do we prevent people from misleading others using statistics? How do we prevent people from using statistics to mislead others? Well, there is no real stats police that's going to come after you, throw you in jail or issue you a fine. But the way we're going to minimize the possibility that you're being misled, first and foremost, depends on where you're getting your data from, your information from. All right, media sources vary in credibility. So if you pick up a National Enquirer magazine while you're waiting in line at Walmart to check out, chances are whatever information you're getting from that magazine has maybe, 5% truth and 95% misleading information. And people know that. They're just picking it up to be entertained because, maybe, Michael Jackson did father 500 children or whatever the National Enquirer is claiming. All right. So popular magazines, there really is no way of preventing them from misleading you. There's no checks and balances. But at the other end of the continuum, we have academic journals, and those academic journals make some effort of providing you with credible information, and we do have a form of police that's going to make sure the information is credible. So let's talk about our policing method. All right. Within academic journals, some of them are peer-reviewed, also called refereed. Those two things mean the same thing, peer-reviewed, refereed. Now, not all academic journals are peer-reviewed, but a lot of them are. And any journal, academic journal that is peer-reviewed has the most chance of providing you with information in a way not to mislead you. In other words, you can have more faith, more confidence that what you're reading in a peer-reviewed journal is highly credible. Now, how do they do this? Well, let's say I did, some research and I want to publish it in a journal. I'm going to send my research article to the journal's editor. And then the editor is going to look at it and say, this is not really appropriate for our journal. You really want to submit to this other journal. They publish stuff like that. And in which case they'll just tell me no. Or the editor might say, you know what, I looked this over and I think this is perfect. I think that it's timely information. We want to proceed to the next step. The next step would be the editor sending out my article to 2 or 3 other researchers who are doing similar types of research as mine. And typically, I don't know who those reviewers are, and they don't know me. It's called a blind review. We don't know, each other's identity. But these other reviewers, they're experts in their field. And so they will review my research and my article, and they'll look at my statistics, and they'll look at every aspect of the journal article to make sure that I'm not trying to mislead anybody. And then typically what happens is the reviewers will make some comments, and if there are minor revisions, then I would get a letter back from the editor saying, these are the comments from the reviewers, and please make the changes, resubmit. But if they feel I have deliberately misled, then my reputation is at stake, right? But it could go beyond my reputation being at stake. Because here's the thing, peer review is not foolproof. Reviewers sometimes miss an out-and-out lying or cheating. They sometimes miss misleading statements or incorrect statistics. And the consequences can be really severe. So think of this, right? So many people right now all around the world mistrust vaccinations because one doctor in the UK came out with a study saying that the MMR, measles, mumps, rubella vaccine, increases the risk of autism. And that research article was peer-reviewed and it was published. Only later was it found out that he lied. It is not the case that there's any association. Wait, it is not the case. It's the case that there is no association between the vaccine and autism. He made up his data. He fabricated it. The people who reviewed his article didn't catch that. But look at the consequence. Now people mistrust a lot of vaccines. Some people mistrust all vaccines. Even though this research was shown to be false, he admitted it, and I'm not sure what happened to him. Certainly he doesn't have a career anymore, not in medicine. I don't know if he went to jail. He probably had to pay some restitution. So if his research was being paid for by a government grant, he probably has to pay that back out of his personal funds. But he has single-handedly had such a negative impact on our society because people who might not have otherwise gotten sick got sick because of his cheating, if you will. All right. So that concludes chapter 1.